Yeah, it's stiff. Almost there. Oh yeah. Balls down. You dirty pump. Oh yeah. Disturbing if you are N43 engine owner. Hi, it's Zen with another video, and this time I will be doing the final assembly on a BMW N43 engine, and that's because I'm currently in the middle of a pretty big rebuild. Some time ago I bought this BMW 1 Series with some engine issues, and when I did some diagnosing I found a lot of bearing material inside of the oil, and the oil filter actually had holes inside, so that was a pretty bad sign. So I've decided to pull the engine out of the car and do some further investigation, and when I removed the oil sump I found the reason of this bearing material inside of the oil. So the pickup was totally clogged with these little plastic pieces, and these are the pieces of a broken chain rail guide. So this is a very common issue on these engines. Once the pickup mesh is clogged, the oil pump can no longer supply the engine with enough oil, so that caused 3 spun bearings on the con rods, and that means that the whole engine has to be rebuilt. So in the first video I've rebuilt the bottom end, and I had to replace the crankshaft and the con rods, and I also had to do a massive cleanup job. And in the second part I had to rebuild the cylinder head, I had to polish the camshafts and the camshaft journals because they were quite damaged. I've also replaced the valve stem seals. I've also checked and cleaned all of the lifters, and I also lapped the valves. If you are interested in this whole procedure, I have plenty of videos, so I'm going to put the links down below in the description and up in the cards. Check them out. They can be quite informative, funny, sad, and disturbing if you are N43 engine owner. Now I have to install the cylinder head back onto the engine block, and I still have a whole box of parts here that I need to install. And after that I can do the timing procedure and finish installing all of the accessories, the sensor, the high pressure fuel pump and all of the lines, and basically get the engine ready to be put back into the car. Enough talking, let's go! The cylinder head is ready to be installed. I just have to clean the bottom surface a little bit and make sure that it's totally clean. Now I'm going to do the final cleaning of the surface of the engine block. I'm going to turn the engine block upside down and make sure that there is no liquid or oil inside of the holes for the cylinder head bolts. That could damage the engine block because of a hydrolock. Now I have to install the check valves for the VANOS lines, and I already cleaned them and checked them out, so they do hold pressure, and these two have to be installed balls down. And I have to make sure that they are all the way down. And now I have to install the crash gaskets. This gets sandwiched between the block and the cylinder head, and they are new from BMW. Now I can install the new head gasket. The head gasket also comes with this handy instruction sheet, and it has all of the torque values here, so you can't really mess this up. There's also a locating pin here at the front. This is a 0.4mm head gasket, and that's because I did not resurface the cylinder head, so this is still original thickness. But if you are resurfacing the cylinder head, you have to then use a thicker head gasket. Okay, it's time I put the cylinder head back on the block. And you have to catch it on the 2 dowels. And it's in. Just making sure that everything fits perfectly and that there's no gap. Here I have the new head bolts, and I had to clean them up a little bit, and then I applied a very light thin coat of oil onto the threads and also to the bolt heads, so they are supposed to be oiled up, and the washers are cleaned but not oiled. There are 3 different sets of head bolts, so these are the biggest and they have the corresponding washers, and the smaller washers correspond to the smaller bolts. Now I can start inserting the bolts. So the bigger bolts fit in these locations, and one at the back on the intake side. The two front bolts are a bit trickier because you have to get the washer in first, and then you can install the bolt. Otherwise, the washers won't clear the springs. And finally, the smallest head bolts, two at the front and one at the back on the exhaust side. Now I'm just going to make them hand tight. Now I have to torque the bolts to 30 Newton meters, except these two at the front, they have to be torqued to 10 Newton meters. I have to start with this bolt here, and then I go to this bolt here, and then I have to jump to this side and on the other side, and then this one here and on the other side, then the two bolts at the back and the two at the front. As I've said, these two are torqued to 10 Newton meters. After torquing them with a torque wrench, I'm going to mark all of the bolts so I know in which stage of torquing they are. Now I have to rotate them all to 90 degrees, and I'm going to use my angle gauge again. However, I removed this stopper here, and I have an adapter to 3/8 of an inch and the socket. So this gives me just enough space here to insert it, and with this thing removed, I can now use only this bolt here as a stop. So I'm going to make sure that I have a good grip, and then I'm going to align the angle gauge, and I'm going to pre-tension everything so it's set to 0. Now I can do 90 degrees. And now I repeat the process for all bolts. The first round of 90 degrees turn is done. I had some issues inserting this tool into these tight spaces. So what I did is I used an extension and I've put it like this, and then I installed my handle. I gave it some pre-tension, and then I've set the indicator to be parallel with the engine, and then I just did a visual 90 degree. So I was rotating and visualizing 90 degrees. For these smaller bolts, I don't think that's too problematic. I think it's close enough, but the main bolts definitely have to be more exact. So as you can see, it's definitely better option to get the magnetic version of this angle gauge. The next round of rotating is for the main bolts only. So the main bolts get rotated 90 degrees, and the smallest bolts all the way at the front are already torqued to the final value. And the final rotation on the M10 and M9 bolts is 45 degrees. And I'm done installing the cylinder head. Now I can start installing all of these parts. First I'm going to install the rocker arms. I've cleaned all of the surfaces, so now I can apply a little bit of oil onto the bearings. In goes the intake camshaft, and I have to make sure that these cutouts in the intake camshafts are oriented toward the center of the engine. These are reliefs for accessing the head bolts. Here's the exhaust camshaft. This has to be oriented in a way that the first two lobes are pointing towards the center of the engine. And definitely don't mix up the camshaft. The exhaust camshaft has this triangle shape here for the high pressure fuel pump. And now I can start fitting the bearing cups. They are lubricated and they are also marked. On the intake side, they are marked from E1 to E4. I'm also going to put a bit of oil onto the camshaft. And in goes number 1, number 2, number 3, and number 4. Now I'm going to put on the 10mm nuts. And now I'm going to make the nuts hand tight, and I'm going to start with this bearing cup here. And then I'm going to move to number 2 and number 4 and then number 1. And I'm going to repeat this process until all of the bearing cups are nice and tight. And I'm going to repeat the process on the exhaust side. Number 1 and number 4. And I always forget to fit these oil line brackets. Yeah, so now I have to remove a couple of nuts. These old brackets hold the oil line and they fit underneath the nuts. So on the intake it's here. On the bearing cup number 1 and 4. Hey, it's me from the future. I've just finished installing the oil line and I realized that I've put one of these brackets wrong. So this is not the correct position. It must be on a number 2 bearing shell. You can actually see the witness marks here. So yeah, I'm doing it wrong. Now back to the past. And also on the exhaust side, the tightening order on the exhaust side is the same. And finally, I'm going to install this front bearing shell. And I'm also going to make it hand tight. Now I have to make sure that all of the rocker arms are perfectly aligned on the valve stem. And now I have to torque all of the nuts to 10 Newton meters in the same tightening pattern. Done with the camshafts. Next I want to install the chain drive, and to do that I first have to assemble it, but even before that I have a fun fact. So the swag timing kit or the chain kit is exactly the same as the BMW kit. So if I take a look at the markings on the chain, I can see that it's actually the same company that is on the OEM parts, and also here you can see it's the same marking as on the original. So sometimes you can save some money and just buy good quality German parts, and a lot of times they are just repackaged OEM parts or from the same manufacturer. Now let's do another quick and fun thing. Here is the new chain and here is the old chain, and let's check how stretched the old chain is. So I'm going to put both chains here on this bolt and I'm going to align them. Now let's check the length. And yeah, it's quite stretched, like half a link stretched. It's not critical, but still it's definitely worth replacing. And this engine had 216,000 kilometers on the odometer. I also have the old and the new sprocket here, and if I compare them, I can see that the old sprocket has definitely some wear on it. It's not catastrophic, but still you can see where the chain eats into the sprocket. Let's compare it in this view. Yeah, you can just about see the wear. It's definitely a good idea to replace the drive sprocket as well when you are replacing the chain. Now let's assemble everything together. So first I have to feed the chain through the guide rail. And here I have to carefully pry apart this plastic part, and it can break, so be careful, nice and slow. And now I have to install the sprocket, and the collar on the sprocket must face towards the back of the engine, so towards the crankshaft. And now I can just pull the chain tight. And now I can click into place the upper part of the chain guide. I just have to make sure that the chain is in between. And there are 4 tabs here, and you just have to hear it click. And it's in. There are 2 journal bolts that hold the rail, and the bigger one is at the bottom and it goes right here. And the smaller one is at the top and it goes here. Now I'm going to use a zip tie to keep the chain nice and tight so the sprocket doesn't fall out. And now it should be pretty easy to slide this in. Now I can install the upper journal bolt and the lower journal bolt. The lower journal bolt needs to be torqued to 20 Newton meters. And the cap needs to be torqued to 32 Newton meters. And the upper journal bolt needs to be torqued to 14 Newton meters. And the cap to 25 Newton meters. Now I'm going to install the main hub, but this is just temporary. This is so that the sprocket on the chain doesn't fall out. I'm going to use the old bolt. And I'm just going to make it hand tight. Now I'm going to cut the zip tie and release the chain. Now I can install the VANOS units, and just so you know, I've disassembled both of the VANOS units and cleaned them thoroughly because they were totally packed with bearing material and they were probably sticking or binding. I have a video on that if you are interested. It's not like I recommend doing this, but it can be done. Check it down in the description and up in the card. And I have to make sure that all of the mating surfaces are clean, and also here on the camshaft I have to make sure that everything is totally clean. There are markings on the VANOS units. This one is in or ein. This is the intake side, and you must not switch that around, otherwise you're gonna have issues. Here's the exhaust VANOS unit. This one is a bit more tricky. But eventually it gives up and then you can install it. And finally I'm going to install fresh new bolts. They have to be replaced because they are stretched to yield. And I'm going to make them hand tight. And then I'm going to back off 1/4 of a turn. And that way the VANOS units can rotate freely and the camshafts stay in place so you cannot bend the valve. And then I can install the 2 bolts holding the upper chain guide. And these 2 need to be torqued to 8 Newton meters. Now I'm going to install the oil filter housing and the oil cooler. However, before that, I still have to clean it, and I also have to replace the gasket between the oil cooler and the housing. First, I'm going to remove the old gasket. This one is still pretty pliant and soft, so it could be that it was replaced before. Now I have to remove the 4 Torx bolts holding the oil cooler. Now I can remove the gasket and the filter cap. And now I have to clean all of this. I wet sanded the surface so it's nice and smooth, and now I can install the gasket. I'm going to put a very light coat of oil on it. And now I can put back the cooler. There are two pins that need to engage. And now I can reinstall the bolts. These bolts have to be torqued to 8 Newton meters. Now I can install this gasket here. And again, I'm going to apply a little bit of oil. And now I can install it. And these have to be torqued to 9 Newton meters. I'm also going to install the filter. So I have the new kit here that comes with all of the gaskets. So first I need to remove the old O-rings. It's very important you replace all O-rings. If these inner O-rings fail, you will not have any oil pressure, and that's gonna be a very bad day. Now I'm going to put some fresh oil here. And I'm also going to oil up the O-rings. And now I can install the oil filter element. And now I can install it. And this only needs to be hand tight. Done with the oil filter housing. Now I want to clean the oil lines and make sure that there is no debris inside and that all of the nozzles are working and they're not clogged up. So first I'm just going to spray in some brake clean. It looks like that a couple of nozzles are pretty clogged up. I'm also going to try and blow some air into the line. I'm going to put in some WD-40. I've put a piece of silicone tube at the end and I'm going to try and blow the dirt out from this direction. They're slowly beginning to open up, but it's still a work in progress. Whoa, that took a lot of work and time. So eventually I managed to unclog them, and what I did is I've blown air through each and every of this little nozzle, and then I sprayed in brake clean, I sprayed in WD-40, I put some soap in, and I've just repeated the process, and then I tried to tap out all of the dirt. There was quite a lot, but eventually all of the nozzles opened up. So let me demonstrate how that looks like. So I'm going to spray a little bit of WD-40 in. And you should see that WD-40 comes out from every nozzle. Let's try the exhaust side. So this is really critical part of the rebuild. You have to make sure that these lines are clean and they are really clogged up with the debris. And now I can finally install them. So the exhaust side goes here. And the intake side goes there. And now I just have to reinstall the banjo bolts, and they have to be torqued to 9 Newton meters. Now I have to clean and prepare the vacuum pump. This provides vacuum for the brake booster, so it's kind of important. There are 3 gaskets. The first is the O-ring between the cylinder head and the housing. And then there's another gasket between the backplate and the body of the pump. And the third gasket is an O-ring between the nozzle and the housing. However, the problem is that BMW will only sell you this gasket here between the cylinder head and the housing. And you have to go online and order a special repair kit for this kind of vacuum pump. And then you can replace all 3 seals. However, I don't have that kit, so I really don't want to remove the backplate because I don't want any leaks here. So what I'm going to do is I'm just going to try and clean the vacuum pump as much as I can without opening it. So there is a small mesh here, and this is where the oil enters the vacuum pump and then it exits via these 2 flaps on the side. So my plan is to first clean this dirt here and then fill it up with WD-40, brake clean and then oil, and just try and get out as much dirt as possible. You can see here that there's quite a lot of dirt on that mesh. After further inspection, I realized that I can actually remove this mesh. So I took a very small screwdriver and I managed to pry it out. So it's a bit delicate, but it can be done. Here it is. Now I should be able to clean it really well. You can see how clogged it is. Yeah, definitely needs cleaning. And it's nice and clean. I've cleaned the intake port with a little bit of brake clean, and now I'm going to pump in fresh oil. And when I rotate the pump, it's gonna expel oil. Oh yeah, it's dirty. You dirty pump. Oh yeah. Now I just have to repeat this process until clean oil comes out. And here's the oil. And here's the vacuum pump that is now nice and clean, I hope, on the inside. And now I can reinstall the little mesh screen. Now I can install the O-ring. Come on! I'm going to put a little bit of oil on the O-ring and now I can place it in the channel. Now I have to match the rotation of the camshaft. And I have to be careful that the O-ring doesn't slip out of the channel. And now I can install it. I have to make sure that it engages with the camshaft. Now I can install the 3 10mm bolts, and they have to be torqued to 9 Newton meters. Hey, it's me again from the future. Yeah, I forgot to install this little carrier bracket here at the vacuum pump. Now I can install the oil pressure sensor. It has to be torqued to 27 Newton meters, and you are also going to need a long socket for this. And the coolant temperature sensor. It has to be torqued to 13 Newton meters, and again you're going to need a long 22mm socket. Now I have to clean all of the solenoids. These 2 are VANOS solenoids, and this one is the oil pressure regulating solenoid. Obviously the best option would be to just replace all of the solenoids, because once the dirt gets into the oil, the surfaces get scratched and the solenoids no longer seal oil, so they're not as effective in regulating the oil flow from one channel to another. So that can definitely give you some issues. However, as I said many times, I'm trying to do this on a budget, so first I'm just going to try and clean them out, and later if I have any issues with them, then I will replace them. So first I'm just going to remove the old O-rings. First I'm just going to give the solenoids a bit of a clean with the brake clean. And now I'm going to use compressed air and try and get all of the debris out of the mesh. If I blow compressed air here, then on the other side the dirt should just fly out. And I find this to be the most effective way. You can see that the mesh is pretty clean now. I'm also going to repeat this process a couple of times. Now I'm going to use a little bit of WD-40. And I'm going to do the same for the VANOS solenoids. Here's the final result on the VANOS solenoid. So the mesh is nice and clean, no particles in there. So now I just have to repeat the process for the other VANOS solenoid. Now I want to make sure that the solenoids operate correctly, and I also want to do some additional cleaning. So what I'm going to do is I'm going to submerge them into this jar full of multi-purpose degreaser, and then I'm going to connect my 12-volt power supply on the terminals. And I also have a switch here which I can operate, and this way I can manually actuate the solenoids. I have my power supply leads connected to the solenoid pins, and now I can submerge it into the liquid. And obviously you don't want to use anything flammable here, because if you have a spark here, then you could combust, and you don't want that. So here's the solenoid submerged. Now I'm going to operate the switch and see if the solenoid moves. And I got nothing. I can't hear anything. Okay, that's interesting. Maybe the solenoid is stuck, so what I want to do is just switch directions. So I'm going to switch polarity, and that should cause the solenoid to be operated in reverse direction. Let's try again. I can't really hear anything. Let's see if I can see the plunger moving or a spring moving. Yeah, I can't really see anything. It looks like the solenoid is a bit stuck. I'm going to try and use a piece of bent wire here, and I'm going to try and grab on the spring and just try and move the plunger a little bit. Okay, let's see if that did anything. I'm gonna try again. I can't feel anything. I'm going to try and reverse the polarity again. Okay, let's see. I can't really feel anything. I'm going to try and tap it a little bit. Maybe it will release. Oh yeah, I can feel something. So I guess it is stuck. Okay, if I tap it this way, then it wants to move. So I guess it's pretty stuck. I'm going to try and submerge it again. If I shake it first in this orientation and then energize it, I can feel it operate. I'm going to try and fill it with WD-40 a bit. Maybe this will work. Oh, you can see all the dirt coming out. Let's see. So I could not get it to move under electrical power. So what I did next is I've sharpened up a chopstick and I've pushed it in the plunger, and now I can force the plunger upwards so I can see it moving. So I'm trying to manually move the plunger in and out and make it loose. I'm also trying to use some WD-40 to flush out the debris. I'm just about able to operate the plunger now. Okay, let's see if I can break it loose. I got the solenoid hooked up again, and let's see if it works. Yeah, it works. Let's try some more WD-40. Okay, it works. Now I'm going to reverse the polarity. Let's see what happens now. It works. Let's try and submerge it into the degreaser. Oh yeah, check this out. Reverse polarity again. I'm done with the first solenoid, and when I tried the same procedure on the second solenoid, it was also stuck. However, when I used a piece of wire and moved the spring, it released right away, so I guess it was not as stuck as the first solenoid. Now this obviously is not a very good sign, and I really do not recommend reusing the solenoids. However, I'm gonna give it a try. If they work, they work. If not, I'll replace it. And for the oil pressure regulating solenoid, I had no issues here, so I guess it was not stuck, and I also managed to clean it without any issues. And with that little debacle behind me, I can now start installing the O-rings. I'm first going to install the smaller O-rings, and I'm going to apply a little bit of oil. And now I have to install it, but I have to be really careful not to damage the O-ring. They're really tiny. I'm going to use some more oil just in case. Okay, now I can install the plastic spacer and the bigger O-ring. I've put a little bit of oil on it. And this solenoid is done. The second solenoid. And the oil pressure regulating solenoid. And this O-ring is different size than these two O-rings, so be careful not to mix them up. I'm going to put some oil on it and make sure that everything is nice and clean, and make sure that everything is oiled up. And finally, I have to torque the bolt to 9 Newton meters. Now I can finally install the solenoids, and I've marked the most problematic solenoid with E. This is for exhaust, and that's the bottom solenoid. I'm also going to oil up the hole, and now I can finally install it. Well, it turns out that it's actually quite hard to push the solenoids in with this thick O-ring. So what I'm going to do is I'm going to install the O-ring first. And now I'm going to install the solenoid. And this way it's pretty easy. And the bolts have to be torqued to 10 Newton meters. Now I have to install the front radial seal, so I'm going to remove the central bolt and the hub. First, I have to make sure that the surface is clean and oil-free. The new seal comes with this installation ring, however, I don't need it because I don't have the hub installed. The seal has two slots on each side, and these slots have to be oriented horizontally, so they have to match up where the block meets the cradle. These two slots have to be filled with a special sealant, and unfortunately I don't have it, so I'm just going to use the same sealant that I use for the block and the cradle. And now I'm going to use a piece of wood and drive the seal in. Now I'm going to wipe out the excess sealant. And it's nice and flush with the block, and this is the seal installed. Now I have to install the hub and the crankshaft bolt, and to do that I first have to make sure that the crankshaft is in top dead center position on the first cylinder. And to do that I have to use this locking pin from the timing kit. And this locking pin goes into the hole in the cradle, and here you can see where it comes out on the other side, and the tip of the locking pin has to engage with this hole on the flywheel. However, the problem is that there's not enough space between the engine stand and the engine for the flywheel, so I will have to suspend the engine back on the engine hoist, and then I will be able to install the flywheel and insert the locking pin. Now I have to install this lifting bracket. The bolts have to be torqued to 20 Newton meters. The engine is back on the hoist, and now I can install the flywheel. There is a locating pin here, and I have to match it with the hole in the flywheel. Now I can install the locking pin through the hole. Now I want to press on the pin while carefully and slowly rotating the flywheel. I think this is it. So now the pin is fully inserted because this handle here is all the way to this wall here, and I can no longer rotate the crankshaft. Now I have to lock the balancing shafts, and to do that I'm going to use this tool. Now I have to rotate the balancing shafts, and the counterweights have to point toward the bottom of the engine, so this is the correct orientation. And now I can slide in this locking tool. And because the engine is at an odd angle, I'm going to use grips and just secure the locking tool in place. Final check, I have to make sure that everything looks perfect, so the chain is nice and tight around the sprocket, and this plastic guide sits on the sprocket as well, so it looks like I can now insert the center hub. I have to center the hub a little bit and make sure that both sprockets fit on the hub. I've lightly oiled the new crankshaft bolt, and now I can install it. And first I have to torque it to 50 Newton meters. Next I have to do 150 degrees of rotation, and that is a bit tricky. So I've decided to put the engine back on the engine stand, but this time I am using a longer stud bolts here, so I can squeeze the flywheel between the engine stand and the engine. However, this is definitely not the best way to do this. I am kind of concerned that I can bend the flywheel or something like that, so I'm really trying to be careful. However, this way it's gonna be much easier for me to do the rotation. To do that 150 degrees, I must not use the locking pin as a stop, because that will damage the pin and the flywheel, so it cannot handle that kind of torque. So what you have to do is use a special holding tool. This is a tool that my father made, and I thank him again. And this tool fits over the hub, and then you can fix it with 3 bolts. And this way you can prevent the hub from rotating. You can also buy the tool online, but in any case you will have to figure something out. I've secured the tool, and on this end I have 2 blocks of wood, so it supports the bar, and this way I don't have to hold the tool while doing the rotation. Now I can insert the angle gauge, and the stop for the angle gauge is going to rest on the handle. So first I'm going to do 90 degrees, and I'm going to set the preload. Let's go. This is 30 degrees now, and now I have to switch to the longer cheater bar. Okay, let's try and go to 90. Now I'm going to try and reach 150. Almost there. Almost there. Okay. Whoa, that was a lot of work. Things are just getting strange now. But at least the hardest part is over, I think. Now I can remove the locking tool for the balancing shafts. And I'm going to leave the locking pin in for the moment, because next I'm going to do the timing on the camshafts. First I'm going to install the camshaft locking tool. As you can see, the mounting flats on the camshafts are not oriented at a 90 degrees angle. So first I'm going to insert the locking tool on the intake. And then I'm going to push it down. And on the exhaust side, I'm just going to remove this piece of the locking tool. And now I can simply push down and secure the locking tool. And unfortunately, it's not that easy because the holes are misaligned and this locking tool protrudes into the oil line. So I'm just going to unclip it and I'm going to push it to the side a little bit, and this way the tool should fit. Now I can install the bolts, and then I just have to make it hand tight. And now I can install the exhaust camshaft locking tool. However, I expect I'm going to have problems again with the oil line, so I'm going to unclip it. And now I think I should be able to fit the locking tool. And let's try and rotate the camshaft. I will have to use both hands for this. Okay, I know. You happy now? Now I can install the front locking tool for the VANOS units, and this tool has 2 pins, and here are the holes on the impulse sending gear on the VANOS units, and they have to line up. I have to undo the bolt a little bit so it can rotate. Okay. That fits quite nicely. Now I can install the 2 bolts that are provided with the timing kit. I'm going to make them just slightly tight. And now I want to check the alignment of the front tool. It's flush here on this side to the cylinder head. Let's check the other side. And there is a bit of a gap, so I'm going to bump the locking tool towards the right. There's a bit of a gap here and a bit of a gap here, so this should be fine. Now I'm going to tighten it down. Next I have to install the pre-tensioning tool for the chain, and I have to screw this in place of the chain tensioner. This has to be tightened all the way in. And now I can screw in this center bolt until I feel it engage with the chain rail. So it's tight now. And now I have to pre-tension the center bolt to 0.6 Newton meters. And this is a bit problematic because usually you don't have such a small torque wrench with such small value. So you can get a beam torque wrench with some smaller scale, or you can get digital torque wrenches. but they're all pretty expensive, so I've come up with a cheaper solution. So I've designed or adapted a design for a 3D printed torque wrench, and then I calibrated it to 0.6 Newton meters. Now it's not extremely accurate, but it's definitely accurate enough to get this job done. If you want to get this tool, you can check out my website and you can order it there. And thanks for supporting my work. Now let's pre-tension this. And when it clicks, it's done. Just a quick tip, if you are doing this job when the engine is installed in the car, you can shorten this central bolt a little bit, and this way you gain some space, so it's easier to do the pre-tensioning. Now I have to torque both bolts to 20 Newton meters. Now I have to rotate both bolts to 180 degrees. And before that, I'm just going to mark the bolts. This way I can verify that I did both bolts correctly. The locking pin is of course still engaged with the flywheel, so that means that the crankshaft is in top dead center position on the first cylinder. I have my angle gauge set up and I have the preload, so now I can set it to 0. And I'm first just going to do 90 degrees. And I'm going to do the same on the intake side. And I'm going to do 90 degrees on the exhaust side again. And 90 degrees on the intake side. Let's confirm. The markings line up. So I'm finally done with the timing. Now I just have to remove all of the locking tools. And I must not forget to reattach the oil lines. Now I can install the new chain tensioner, but before that, for laughs and giggles, let's compare the new and the old. So I'm going to try and squeeze it with my finger. Yeah, it's stiff. It's a pretty good workout for my hands. Let's try the old one. Yeah, definitely not as stiff. I think that this is the previous revision. And this is the latest revision, and it is a bit stiffer. I would say about 20% stiffer. Yeah, I can easily compress this one. And the chain tensioner needs to be torqued to 65 Newton meters. I got the engine back on the engine hoist, and now I can remove the flywheel. Now I'm going to install the rear main seal, and first I need to remove the excess sealant. Now I'm going to clean all of the surfaces. Rear seal also has these two slots, and they have to match the junction between the engine block and the cradle. And now I just have to push the seal together with this installation tool all the way on the crankshaft. Now I can rotate the seal into position and I can start pushing the seal into the slot. I'm going to use the sealant again inside of these little slots. Now I'm going to use the old radial seal and I'm going to place it over the new seal. And now I can use this seal as a guide tool and install the new seal. Now I'm going to use the piece of wood again, and the seal is nice and flush, so now I can remove the installation tool. And the rear main seal is installed. Now I can finish up the bottom side. I've made sure that there are no more debris in the pickup mesh, and now I have to replace the O-ring. Here's the new O-ring from BMW. Well, it's actually not that hard, but still it's best to replace it. Bolts in. 2 bolts are at the back, and I have to be careful not to drop the bolts inside of the engine now. And they have to be torqued to 9 Newton meters. Next, the oil pan. I'm going to give the engine block a little bit of a clean. I'm also going to clean the oil level sensor because it is pretty loaded with bearing material, as you can see. So I'm going to use brake clean and I'm gonna spray it down these holes at the top and at the bottom. And this way I hope that I will be able to clean it out. Now I'm not sure if this sensor is still okay. I will install it, and later if it turns out that it's not good, I can replace it. It's not a big deal. Now I can install the new gasket. And now I can install it back onto the oil sump. And the nuts have to be torqued to 9 Newton meters. Here's the new gasket. Now I'm going to apply a little bit of sealant on the outside of the seal. This is a really small amount of sealant, and this should just be enough to help last this seal a bit longer. Now I'm going to place it carefully onto the engine. Now I'm just going to repeat the process for this side. And now I can finally place the oil pan back onto the engine. Now I can put back the bolts. And finally, they have to be torqued to 30 Newton meters. I'm done, and I truly hope that this is the last time that this engine is inverted. Before I install the valve cover, I want to replace the spark plugs because it's a bit easier than when it's installed. So first I'm just going to remove the cylinders. And before removing the spark plugs, I will have to introduce you to another special tool. This is a 12.14 millimeter articulated long socket for removing the spark plugs on these engines. Yeah, the spark plugs are really down deep and they are mounted at a slight angle. And this means that you will need a special socket for this. Now I have to say that this socket is really good, so it fits perfectly. Let me show you. Like this. And now it's gonna be easy to remove them. Here's the new spark plug, and by the looks of it, it is a slightly different design. So it looks like it is a bit longer. Yeah, definitely longer. I'll have to do a quick check if I got the right ones. Yeah, I've checked, and it's definitely the right one. So the markings match, and I'm not sure if these spark plugs are the correct type for this kind of engine. Well, doesn't matter now. The socket has a special rubber insert that grabs the spark plug. So this way it doesn't fall down into the well and it does not get damaged. So you have to be careful not to drop spark plugs into the well. First I'm going to make it hand tight, and then I'm going to torque it to 23 Newton meters. 1 done, 3 to go. Next, the valve cover. I've got the new gasket here, so first I just need to remove the old gasket. There's one small gasket here. It's not that hard. Maybe it was replaced before, but in any case, it's gonna be replaced now. Now I have to clean the channel. High fuel pressure pump first. So this seal goes underneath. And now the main gasket, and I'm going to start with this U shape here. Okay, now I have to carefully place the cover onto the cylinder head. And finally, I have to torque them down to 10 Newton meters. Now I have to install the spark plug cylinders, and they have to be oriented so that this cutout matches the tooth on the valve cover. So it has to be oriented this way, and I have to push it all the way down. And the cylinder is locked on the catch. Now I'm going to install the high pressure fuel pump and the rail. First I'm going to install new gasket. Now I have to install the plunger for the camshaft, and this plunger is keyed, so I have to make sure that this tab here engages with the slot. I'm going to put a little bit of oil on the surface. I've also noticed that the triangle shape on the exhaust camshaft that drives the plunger is in max position, so I will have to rotate the engine so that it gets to the minimum position. In goes the pump, bolts, and I just want to make them slightly tight. I'm only going to make them so tight that I can still rotate the pump a little bit. This is important for the high pressure fuel lines. Okay, I can just about rotate it a little bit. I've kept the high pressure fuel lines protected in this zip bag during this whole process. I've also designed and 3D printed the protective caps. It's very important to prevent any dirt from ingressing the fuel and fouling the injectors. I've also designed and 3D printed protective caps for the injectors and for the high pressure fuel pump. I'm going to put all of the STL files down in the description so you can download them and print all of these parts yourself. You can also order a set on my website if you want to support my work. I would definitely appreciate that. Now I can remove the caps. Now I can install the fuel line. And first I just want to start the nuts. Just hand tight so that the line can still move a little bit. Now I'm going to start the nuts on the injectors. Okay, they all can still wiggle a little bit. Now I can install the 3 11mm bolts. And they have to be torqued to 30 Newton meters. Now I'm going to finish tightening the nuts by hand. I'm also going to try and nudge the fuel pump a little bit. This way I can feel that the line is not under any tension. Now I can do the final torquing on the high pressure fuel pump, and the bolts need to be torqued to 11 Newton meters. And I want to alternate the torquing so that the pump is not twisted in any way. Nuts on the high pressure fuel pump need to be torqued to 30 Newton meters, but I don't have the attachment or adapter for a torque wrench, so I will have to do it by feel. And that feel is dread and uncomfortableness. That's pretty close. The nuts on the injectors have to be torqued to 23 Newton meters, and again, I don't have the adapter for the torque wrench, so I will have to do it by feel. And I'm going to hold down the nut on the injector with the 13mm spanner. 23 Newton meters. Augenmaß. Now I'm going to install the electric water pump and the lines. There are two gaskets I need to replace. The first is this O-ring on the intake side, and the second is the gasket on the exhaust side. Unfortunately, I forgot to order the gasket for the exhaust side, so I'm just going to reuse it for now, but later I'm definitely going to replace it. It's not that hard to do anyway. The smaller bolt goes to the top side. 2 more bolts at the bottom. They have to be torqued to 40 Newton meters. The top bolt needs to be torqued to 22 Newton meters. Now I have to insert the intake hose and install the bolts, and they have to be torqued to 9 Newton meters. Next, the exhaust pipe, and they need to be torqued to 9 Newton meters. And I can also connect this hose on the oil cooler. Now I can install the front pulley, and I have to make sure that all of the surfaces are nice and clean so that the pulley runs straight. And these bolts have to be torqued to 35 Newton meters, but to do that I first have to make sure that the crankshaft doesn't rotate. So I'm going to use a 22 mm spanner to hold it in place. Next I can install the belt tensioner, and it has to be torqued to 40 Newton meters. Now I'm going to install this little plastic carrier for the AC line. And I couldn't find the specific torque values for this bolt, so I'm just going to torque it to 35 Newton meters. Now I can install the right support arm for the engine, and fun fact, this hole here is tilted towards the rear so that you can tilt the engine if you undo the nuts, and this way it's easier to remove the transmission bolts. The bolts have to be torqued to 38 Newton meters. Now I can install the AC compressor carrier. And the bolts have to be torqued to 23 Newton meters. Next, I'm going to install this support bracket. And I'm going to torque them to 20 Newton meters. Next, the right engine support arm, 38 Newton meters. Now I can install the knock sensors, and I have to make sure that all of the surfaces are clean. The long part of the wire is at the starter, and the bolts have to be torqued to 20 Newton meters. Next, the starter motor. And this bolt has to be torqued to 38 Newton meters. Now I'm going to install the exhaust manifold, and I'm also going to put in new gaskets. And the nuts have to be torqued to 20 Newton meters. Now I'm going to install the EGR valve, and I also have to replace the O-ring. The bolts have to be torqued to 9 Newton meters. Next, I'm going to connect the exhaust manifold to the EGR valve, and I'm going to use a new gasket. And they too have to be torqued to 9 Newton meters. Next, the wiring harness. First, I'm going to reconnect the knock sensors, and then I'm going to put back one of the bolts just to secure it a little bit. And I'm going to attach the connector back on the harness. Now I can start reconnecting all of the sensors. So first is the temperature sensor, and then I'm going to connect the oil pressure sensor and the oil pressure regulating solenoid and the starter motor and the crankshaft position sensor. And this cable carrier clips onto the engine block. and the oil level sensor. Next, I can install the distributing boxes for the coils and the injectors. I just have to press them in. Then I can reconnect the injectors. I have to make sure that the connector is all the way in. Next, grounding wires for the coils. And the nuts have to be torqued to 7.5 Newton meters. Next are the coils. They have to be rotated 45 degrees, and I have to push them down on the spark plugs, and then I can install the plug and close the latch. Then I have to connect the high pressure fuel pump connector and the fuel pressure sensor. Now I have to connect the EGR valve, and I'm going to use a zip tie here for the cable. Now I'm going to do the front end of the engine, so I have to attach this front harness here. And at the front I can connect the VANOS solenoids and the camshaft sensors. And then I can secure the distributing box with a 10 mm bolt, and it has to be torqued to 9 Newton meters. And I'm going to secure it here temporarily with a nut. There's another bracket here that holds these two hoses. However, I'm going to install that bracket when I install the engine, so that it's not in the way. And then I can connect the water pump and the thermostat. And finally, I just have to connect this water pump grounding wire. And finally, this bolt has to be torqued to 19 Newton meters. And I'm finally done reassembling the engine. So this is gonna be the end of the video and the end of the N43 engine rebuild series. And in my next video, I'm going to install the engine back into the car. And I'm also going to install the intake manifold and the transmission. And after all this time, effort and money invested, I really hope that this engine actually performs as expected. Yeah, it's gonna be interesting, so stay tuned, consider subscribing and liking. Thanks for watching, keep zen and continue the art of BMW maintenance.